Imagine waking up to find out Earth suddenly has not one, but two moons. Sounds impossible, right? Well, NASA just confirmed a tiny new companion orbiting alongside us. Asteroid 2025 PN7, a so-called quasi-moon. It's not a true satellite like our moon, but it's been quietly following Earth for decades, almost perfectly in sync with our orbit around the Sun. This rare find could reshape how scientists understand near-Earth asteroids and planetary motion. So what exactly is a quasimoon? How long will it stay with us? And why does this discovery matter for future space missions? Let's find out. NASA confirmed that a small asteroid named 2025 PN7 has been moving almost lockstep with Earth. Discovered by astronomers at the University of Hawaii's Pan-STARRS 1 telescope in August 2025, it's estimated to be between 18 and 36 meters wide, roughly the height of a four-story building. What makes it extraordinary is its 1:1 orbital resonance with Earth. It orbits the Sun in nearly the same time we do. But here's the twist: 2025 PN7 isn't gravitationally bound to us like the Moon. Instead, it's caught in a cosmic rhythm where Earth's gravity gently tugs it into step, creating the illusion that it's orbiting our planet. Think of it as a shadow runner, pacing alongside Earth on the same solar track. At its closest, it's about 4 million kilometers away, and at its farthest, nearly 17 million kilometers far beyond the Moon's range. Astronomers call such objects quasi-satellites, and they're incredibly rare. In fact, only 8 have ever been confirmed. Each discovery helps scientists refine models of how asteroids move near Earth and even assess which ones might be accessible for future missions. 2025 PN7, in short, isn't just a rock, it's a window into the delicate dance of orbital mechanics. You might wonder, how do scientists even spot something so small, moving invisibly across the vastness of space? It started with a faint speck on the Pan-STARRS telescope at Haleakala Observatory in Hawaii. Astronomers noticed the dot was moving, but oddly, it wasn't moving away like most asteroids. It was pacing us. Over weeks, as data piled up, orbital models revealed the truth. 2025 PN7 was looping around the Sun in near-perfect synchronization with Earth. NASA's Jet Propulsion Laboratory then ran simulations confirming it had likely been tagging along for around 60 years, unnoticed, and if all stays stable, it will continue until about 2083 before drifting off into deeper space. These analyses rely on detailed sky surveys that track the tiniest motion of near-Earth objects. This discovery shows just how far our detection capabilities have come. 2 decades ago, such a small object would have gone completely unnoticed. But thanks to AI-assisted tracking, we can now map movements of rocks barely 20 meters wide, millions of kilometers away. For planetary scientists, that's gold, because each one gives new insight into how gravitational forces shape the solar neighborhood. At first glance, 2025 PN7 might seem like just another space rock. But its orbit tells a much bigger story about Earth's gravitational influence and solar system dynamics. Quasimoons like this one reveal how planets can temporarily capture nearby asteroids into complex orbital dances without ever fully owning them. That's crucial for several reasons. First, it helps scientists predict the paths of near-Earth asteroids, some of which could one day pose risks or opportunities for exploration. Second, quasimoons are perfect testing grounds for future missions. They're close enough for robotic probes to reach without massive fuel costs, and stable enough to study long-term. Imagine NASA or private companies sending a lander to a temporary moon just a few million kilometers away. Even more fascinating, studying these objects may help us understand how our own moon formed billions of years ago and how small gravitational interactions shape the architecture of our solar system today. So while 2025 PN7 won't ever outshine the real moon, it's an astronomical reminder that space around Earth is more alive, dynamic, and full of surprises than we ever imagined. Earth hasn't truly grown a second moon, but for now, we have a tiny cosmic companion riding beside us on our endless journey around the Sun. Asteroid 2025 PN7 may be small, yet its discovery is a huge leap for understanding how gravity choreographs the solar system's hidden dances. It shows that even in our familiar orbit, space still hides mysteries waiting to be found. As telescopes and AI tracking improve, Who knows what other tag-along neighbors we might uncover next? So keep your eyes on the skies. Our little quasi-moon will be with us until 2083.